Hi and welcome to the Calculus CLEP review, and this is sponsored by J Digital Tutoring Solutions. Now I'm going to go over what this video is going to cover. First, we can go over what the test covers, what material that it will cover, how you can study for it, and then we'll go over a few review problems. So 10% of the test is over limits. They include statement of properties, limit calculations, and continuity. 50% of the test covers differential calculus. This includes definitions of derivatives, derivatives of elementary functions, derivatives of sums, products, and quotients, derivatives of composite functions, implicit differentiation, derivatives of inverse trig functions, higher order derivatives, mean value theorem, L'Hospital rule, and applications of derivatives. And 40% of the test is over integral calculus. This includes antiderivatives, integration by substitution, distance and velocity from acceleration, growth and decay, Riemann sums, properties of definite integrals, fundamental theorem, average value of a function over an interval, and finding the area in between curves. So what is the CLEP? So this is a way to obtain college credit without taking the class at the college. And you might want to do this if you've taken a class somewhere else, you already have this knowledge. Maybe you took it in high school, maybe you took it at a different college but it wouldn't transfer over. But if you already have this knowledge and you don't want to take the class again, you can take the CLEP. And at the time of this recording, the CLEP is about, somewhere between $80 and $90. So what if you haven't taken calculus yet, but you're ambitious enough to learn it on your own? So there are various ways you can study for this and pass it. So one way is to, buy a book that has the material that the CLEP will cover. So there's one book made by REA called CLEP Calculus. If we look here, you can see here it has an online diagnostic test that pinpoints exactly what you need to study. It has a comprehensive review with test taking tips. It has 2 full-length tests with detailed answer explanations. And it has powerful online tools designed to boost your score. So this is one way for you to study, and there's various other books you can buy. Another way to study for the Calculus CLEP is to go to modernstates.org. They have this calculus course that you can take, and it's absolutely free. So if you look here, this is from their website. They have a module. They have 5 modules. The first module is over limits, then the theory of derivatives, the application of derivatives, theory of the integral, and applications of the integral. So it goes over basically all the material that you would find on the CLEP. So this is going to include videos that teach the material and practice problems for you to try out. So this is from their syllabus. This is section dealing with limits. You can say there's each of these modules that you can go through, and you can do the check understanding to do some practice problems, but each module has a video that you can watch and material for you to read. Like I said, each module has a video that goes along with it. He teaches the material and goes through some practice problems. Here's an example problem that you would see, and they give you various answer choices. You would select the one that you figured out it to be, and if you get it wrong, there'll be a detailed explanation of how to solve it. Now the best part is that they give you a CLEP voucher, which basically means that they will pay for you to take the test. So if it's normally between $80 and $90, you'll be taking the test for free. Now they are a non-profit company, so they're raising money in order to pay for people's CLEP exams. And you're allowed to get more than one. So let's say you're taking calculus and then you're taking some humanities class, and you get a voucher for each one. So this is the first of our practice problems. So it says, what is dy dx of y equals the quantity x plus 1 times x minus 1 times x plus 5. So the first thing I want to do here is multiply these all together. I'll take the first two first and just do FOIL. So that's going to be x times x to give me x squared. X times negative 1 give me negative 1x. 1 times x give me plus x. And 1 times negative 1 give me negative 1. If I combine like terms, the x's go away, give me x squared minus 1. And then I want to multiply it by x plus 5. So x squared times x is x to the third. X squared times 5 is 5x squared. Negative 1 times x is negative 1x. And negative 1 times 5 is negative 5. Alright, so now I want to take the derivative of this function. So remember, the exponent is going to come out front. And you're going to reduce the exponent by 1. And this is just using the power rule. So now I'll take the 5x squared. The 2 is going to come out front. You're going to multiply that by the 5 that's there. Give me 10. And then the exponent goes down by 1. Goes from 2 to 1. So that's 10x. And negative x becomes, the 1 comes out front. And then the exponent goes from 1 to 0, which is going to be 1. X to the 0 power is 1. And then the derivative of negative 5 is just going to be 0. So our derivative is going to be 3x squared plus 10x minus 1. So in our second problem, it says if f of x is equal to x times the square root of 3x squared plus 1, find the first derivative. Now in this one, we have basically two pieces, the x and the square root of 3x squared plus 1. So we're going to need to use the product rule on this. So that basically states it's going to be f of x times the derivative of g of x plus g of x times the derivative of f of x. Alright, so we do that. This first piece is going to be x here. I'm going to change the square root to exponent. That's going to be 3x squared plus 1 to the 1/2 power. Okay, so I'm going to leave x the same and then find the derivative of this. Okay, so first I take the derivative of the whole quantity. So I got 1/2, so it's going to be 1/2 moves out front. And then the exponent, you subtract 1, so it's going to be negative 1/2. Then I need to take the derivative of the inside. Derivative of 3x squared. The 2 is going to come out, so 2 times 3 give me 6. And the exponent on the x is going to be reduced by 1, give me x to the first, so 6x. So that's the first part. Now if I do the second part, it's going to be g of x, which was the quantity 3x squared plus 1 to 1/2 power. And then derivative of just x is just 1. So if I reduce this first one here, I have a negative exponent, so that's going to move to the bottom of the fraction. So that's going to be square root of 3x squared plus 1. And then the 1/2 times 6 is going to be 3. So I have an x and another x to give me x squared. So I have 3x squared over the square root of 3x squared plus 1. And this other one is going to be the square root of 3x squared plus 1 because it has a positive 1/2 exponent. Alright, so from here I want to combine these two. So basically the common denominator would be square root of 3x squared plus 1. So if I do that, it's going to be 3x squared over square root of 3x squared plus 1 plus Basically, the square root of 3x squared plus 1, that's going to be squared over square root of 3x squared plus 1. So from there, we have 3x squared over the square root of 3x squared plus 1. And the top, if I square that, that's going to be 3x squared plus 1 over the square root of 3x squared plus 1. Now I can add the numerators. 3x squared plus 3x squared is 6x squared. And then plus the 1 over the square root of 3x squared plus 1. And that's going to be my final answer there. And this problem reads, which of the following is an equation of the line tangent to the graph of f of x equals x to the third power minus x at the point x equals 2. Now here we want to find the slope of the line that's the tangent. In order to do that, we take the first derivative of our function. So we have x to the third minus x. Okay, so 3 comes out front, it becomes x to the second power, and the derivative of negative x is just going to be negative 1. And then I'm going to plug in x equals 2. So it's going to be 3 times 2 squared minus 1, or 3 times 4 minus 1, which is 12 minus 1, or 11. Alright, so that's going to be our slope of our equation. If we look at the answer choices, it's in the y minus y1 equals m x minus x1. This is the point slope formula for a line. So our m is our slope, so we know that's 11. So right now we know that answer choice D is the correct one. Now if we go back to the original equation, if we plug in 2, x to the third minus x, so that's 2 to the third minus 2, 2 to the third is 8, and minus 2 or 6. So that's our point. We plugged in 2 for x and get 6 as our result. So that's our point, and our slope is 11. So our answer choice D would be the correct one. So this problem says, let f be the function defined by f of x equals x to the third power minus 6x squared minus 15. At what value of x does f have a relative maximum? Now if we look at a curve like this, relative maximum would be the highest point in that interval. And if we were to draw a tangent line at that spot where it hits at that very maximum there, that line would be horizontal and have a slope of 0. Remember, if we take the first derivative of the function, that will give us the slope of the tangent line at that point. So if I take our function here, x to the third minus 6x squared minus 15, I take the first derivative, bring a 3 out front, reduce the exponent by 1, and then 2, bring out the 2 out front, 2 times 6 is 12, and then x to the first power, and then derivative of negative 15 would be 0. Alright, so this will give me the slope of any tangent line at any particular point. If I set that equal to 0, because I want to find what x value would have a slope of 0, I can factor out an x here and a 3. That'll give me x here minus 4. That'll be equal to 0, so I can either have 3x is equal to 0 or x minus 4 is equal to 0. Over here, divide both sides by 3, x equals 0, add 4 to both sides here, x equals 4. So I have two choices, x equals 0 or x equals 4. I want to find the relative maximum, so I need to plug that in to our function and see which one gives us the highest y value. Alright, so I'll plug in 0, that'll be 0 to the third power minus 6 times 0 squared minus 15. It's going to be 0 minus 0 minus 15, or just negative 15. Now if I try 4, it's going to be 4 to the third power minus 6 times 4 squared minus 15. It'll be 64, 4 to the third is 64, minus 6 times 16, 4 squared, minus 15, or 64 minus 96 minus 15. That's going to give me negative 47. Okay, so the negative 15 is going to be higher. So our value of x equals 0 is going to give us the relative maximum. And what ends up happening is that x equals 4 is actually a relative minimum. Okay, so I'm going to give you another slope of 0, but it's going to be the minimum point. So the correct answer here is x equals 0. So this one reads, what is the limit as x approaches 0 from the negative side of 2x divided by the absolute value of x? So to figure out the limit here, I'm going to plug in the value for x that is close to 0 but not quite 0. And it's going to be from the left side, it's going to be negative. I can do 0.001. If I do that, it's going to be 2 times negative 0.001 divided by the absolute value of negative 0.001. Okay, so that's going to be 2 times negative 0.001. And the absolute value of negative 0.001 is going to be positive 0.001. If I do that, basically these will cancel out. You just have negative 1 times 2 to give you negative 2. Now if I were to try another number, I could do negative 0.00005, let's say. We do the same thing, 2 times negative 0.00005 over the absolute value of negative 0.00005. Again, that's going to give you 2 times negative 0.0005. And the absolute value of that is going to be a positive 0.00005. Again, this is going to cancel out, give you negative 1. And 2 times negative 1 is negative 2. So our limit here as x approaches 0 from the left side is going to be negative 2. And so this problem said the acceleration at time t of a particle moving along the x-axis is given by a of t equals 20 t to the third power plus 6. At t equals 0, the velocity of the particle is 0, and the position of the particle is 7. What is the position of the particle at time t? So to do this problem, you need to know the relationship between distance, velocity, and acceleration. We have distance, and then distance divided by time gives you velocity, distance over time, and velocity over time gives you acceleration. So if I take the derivative of the distance formula, that will give me the velocity formula. If I take the derivative of the velocity formula, that'll give me the acceleration formula. Now in this problem, we're actually going in the other direction. We're going to go from acceleration to velocity to distance. So to do that, we need to take the integral each step. So if we start with 20 t to the third power plus 6, we're going to take the integral of that. So we're going to raise our exponent to 4 and divide it by that value. So we get 20 t to the fourth power divided by 4. And then we're going to have 6t. And we have our constant value. And they tell us at time equals 0, the velocity is 0. So our c will be 0. So 20 divided by 4 is 5, so 5 t to the 4th plus 6t. So we integrated the acceleration, so this is going to be our velocity. Now if we take that and integrate it, so that's going to be t to the 5th power divided by 5 plus t, 6t raised to the 2nd power divided by 2 plus the constant. Okay, so this is our distance formula. And at t equals 0, our position is 7, so c is 7. So 5 over 5 reduces to 1, so t to the 5th power plus 3t squared plus 7. Okay, so that would be our position of the particle at time t. And this one says the function f is given by f of x equals 3x squared plus 1. What is the average value of f over the closed interval 1, 3? Now to find the average value of a function over a certain interval, we're going to do 1 over b minus a, and the integral from a to b of f of x. Okay, so we're going to do the integral, evaluate it from b to a, and multiply by 1 over b minus a. And in this case, a is 1 and b is 3. So if we look at our function, 3x squared plus 1, to find the integral, I'm going to move the exponent up to 3 and divide by that value. Same here, 1 becomes x. And here 3 divided by 3, just 1, so x to the 3rd plus x will be our integral. Now we're going to take our x to the 3rd plus x and evaluate it. Okay, so that's going to be 3 to the 3rd power plus 3 minus 1 to the 3rd power plus 1. That's going to be 27 plus 3 minus 1 plus 1, or 2. That's going to be 30 minus 2, or just 28. And then we're going to multiply it by 1 over 3 minus 1, which is 1 over 2. So 1/2 of 28 will be 14. So 14 is our average value of f over the closed interval 1 and 3. So I hope you enjoyed this introduction to the calculus CLEP.